Hey guys, today we are going to work through Home Connection page 13 and 14 titled Student Strategies. Before we begin, I'm always going to do the same thing. Make sure my name and number is up at the top, so please make sure yours is as well. And then let's go ahead and let's look at number 1. Juliana loves multiplying by 8 because she can double, double, double. Letter A. Write an expression to show how Juliana would solve 8 times 3. So we've been practicing our 8s strategy of doubling, doubling, and doubling again. So I want you to show me, what would she think of? How would she show doubling once? How would she show doubling again and again? And go ahead and write that out. Remember to use parentheses. I'm going to have you do that right now on your own. When you're done with that, please go on and solve the work that you did for letter B. And then letter C says, write an expression that shows a different way to solve 8 times 3. What's a different thinking strategy that we could use other than double, double, double? I know lots of kids like to use partial products where they divide the 23 into a 20 and a 3. And then take 8 times 20 and 8 times 3. Here's how I would write that with an expression. That's a great strategy to use. For letter C, if you have a different strategy that you would like to write, you sure can. Make sure that you finish A and B right now so you can pause your video while you do that. All right, let's go on to number 2. Kevin was asked to add 6 and 9, then multiply by 17. Which expression shows Kevin's problem? I'm going to give you a minute to circle which one matches up with Kevin's thinking. Then circle it. All right, let's go down to the next one. There's an example down here that I'm going to look through to see how they did their work, because I think that's going to help me. Elizabeth needed to multiply 7 and 8 and then subtract 13. Write an expression to show the problem, then solve the problem and write an equation. So first, this is how she was thinking, 7 times 8, then shows me I should put parentheses, minus or subtract 13. The next thing I do is I actually go ahead and solve it. So 7 times 8 was 56, and then 56 minus 13 got Elizabeth to 43. So let's go down to number 3 then. Caden divided 96 by 12 and then multiplied by 6. Write an expression to show the problem. Then solve the problem and write an equation. So first I'm going to show Caden's thinking. So he did 96 divided by 12, parentheses, because then we have to multiply it by 6. Here's my expression. My equation means that I'm going to actually solve. So to solve this problem, I'm going to rewrite it. (96) divided by 12 times 6. The first thing I'm going to think of in my head is how many 12s does it take to equal 96? So if I want, I can start coming over here and start adding some 12s together. 12 and 12 is 24. Every time I put 2 12s together, I get 24. Okay, maybe I double that. And let's build your way up to 20 or 96 and see how many 12s it takes. Then take that number times 6 to get your answer. You can go ahead and solve. Pause the video while you work on solving that problem. And then you can resume the video when you're ready to flip to the backside. All right, moving on to the backside. Evaluate the following expressions. So evaluate means to actually solve. My first expression looks like this. We know that if everything was multiplication, then I could do it in any order. But since we have a subtraction in there, then I have to solve the parentheses first. So 9 times 7 is 63. Now I take 81 minus 63. 1 minus 3. Can I do that? Nope, I can't. So I have to come over here, take some away from the 80 or the 8. I'm left with 7. Give 10 over here, so I now have 11. Now I have 11 minus 3 is 8. 7 minus 6 is 1. Or 70 minus 60 is 10. So my actual answer is 18. I'm going to circle it. Okay. Next one. 54 divided by 6 times 8. Again, if these are all multiplication, then I could do it in any order I wanted to. But since it's not, I have to do what's in parentheses first. 54 divided by 6. In my head, I'm thinking 6 times what equals 54? 6 times 6 times 9 equals 54. So 9 right here. Now I take 9 times 8 equals 72 and circle your answer. Okay. How many 1 times 1 times 1 cubes, so how many of these cubes are in the following rectangular prism? For each problem, write an expression and evaluate it to find the number of cubes. Again, evaluate means solve. So first, the expression itself is the dimensions. And we know we have to take base times the height to equal how many total number of cubes. So let's find the dimensions of the base. This and this would give me my base. So 1, 2, 3, 4, 5 cubes here. 1, 2, 3, 4 cubes here. So my base is a 5 by 4. That's my very bottom layer. Then I have to do how many total layers there are. 1, 2, 3, 4, 5, 6, 7, 8. Here is my expression. When I evaluate the expression, I'm actually going to solve to see how many cubes. So let's start with what's in parentheses. I think that'll get me to a pretty easy number. 5 times 4 is 20. 20 times 8. I always think 2 times 8 is 16. Then I attach a 0 because it's 10 times larger. So there's actually a total of 160 cubes. Number 7, same thing. Base first times how many layers. That's going to be my expression. So let's do this dimension by this dimension. 1, 2, 3, 4, 5, 6, 7. By 1, 2, 3, 4, 5, 6. My base is a 7 by 6. That's the very bottom layer. How many layers are like that? 1, 2, 3. This is my expression. Now I need to evaluate it, which means I need to solve. I can go any order that I want. I think I really still like solving in parentheses first for this one. I think it'll be easy enough because taking any number times 3 is pretty easy. 7 times 6 is 42. So now I'm thinking 42 times 3. So first I'm going to think of 42 doubled, and then I'm going to add a group of 43, another group. So 42 doubled is 84 plus 43 is my last. I need to add one more group. So 84 plus 43. 4 plus 3 is 7. 8 plus 4 is 12. I get 127. Okay, go ahead and, oops, I'm sorry, I see a mistake I made. Maybe you guys see it too. 42 times 2, and then I have to add one more group of 42. I don't know where I got my 43 coming from. So I got to change this. It's 42, so that means this is a 6. I'm glad I caught my error before I turned it in. When I was looking at it, I was double checking my work, and I noticed that I used 43 instead of a 42. So it's good to always look over your work to make sure you didn't make silly errors. All right, guys, go on to the challenge if you'd like. I will check it when you turn it in. If you have any questions, please, please, please come and ask me. Otherwise, make sure that your name is on it and turn it into the math basket before the due date. Thank you.